Moving into section 1.6, 1.6 is particularly interested in functions. Functions are a really, really big deal in algebra. So let's look over some definitions, shall we? So a relation is a set of ordered pairs. So any collection of points, lines, graphs, all good, right? Anything can be a relation. The domain of the relation is a set of all the values of the independent variable, like the x. And the range of the relation is the set of all the values of the dependent variable, i.e. your y. In other words, domain is every possible x and range is every possible y. Maybe I should make a note of that. All right, so note, domain equals every possible x, or I'm going to put x in quotes because it doesn't have to be x, right? I mean, the letters change. X and y are just the most common. Every possible y value, okay? All of them. Now we're going to deal more with that in a little bit, but I want to first talk to you about the definition of a function. Hold on. There we go. I did a little tweaking there. Okay, so a function is a relation in which each input leads to exactly one output, no more, no less. So I went Google searching for an image or something that would help. Let's see here. This one's not bad. All right, so every time you have, oh, it's from Wikipedia. All right, so every time you have an x, you do something to it, you get a y out, an f of x out. Right, so a function is like a machine. Think of it like your microwave, right? So you take your input, like cold pizza, and you put your input into that machine and you do something to it, and then you get your output, which would be warm, yucky pizza, because pizza's not that good microwaved, all right? But what you can't do is you can't put that pizza in, turn the microwave on, and get two different things coming out. It's not like pizza and broccoli come out, right? It's just pizza comes out, warm pizza, right? So you've done something to it, but it's just still based on what originally was, right? So that's what a function is. It means that every time you have an x value, you could only have one y to go with it. So let me put this over here. Okay. In a function, every x can only go to one y, right? And again, x should really be in quotes because it's not always those letters. But every x can only go to one y value, right? In other words, you can't have an x go to two different values or more. You can't go to three values either, right? So you cannot have an x go to, x in quotes, go to more than one y value, right? That's bad, 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 right? So it cannot happen. All right, now let's keep that in mind as we try to decide whether these relations right here are functions or not. And I'm going to give myself a little more space so I can write right there, because I'm not working on paper, I can adjust this. All right, so you want to look at relation 1 and you want to judge, okay, does every x go to only one y? So look at it. You can't have the number 0 go to two different things. That's bad, right? Think of 0 as like your cold pizza, right? So 0 goes into this relation. Does it get something coming out of it? Sure. Does it get two things coming out of it? No, right? So 0, 1, 2, 3, 4, they all are going to their own separate numbers. Now you might notice down here 33 happens twice. Now that's okay. You can have a repeat in your y. That's totally cool, right? So you can say, okay, 3 went to 33 and 4 went to 33. Like, let's say this is pizza with ham and this is pizza with bacon. Both ways come out warm, mushy pizza, right? So that's okay. But what you can't do is take your, pizza with ham, stick it in, and have two so totally separate things come out, like pizza and a bunny. That would not be good. Okay, so this is totally okay. This is a function. Is a function. And the abbreviation for function, by the way, because I'm lazy, like most mathematicians, is FCN. So if you see FCN, that means function. All right, now let's look at relation number, 2. I was fiddling with my pagination there. Okay, so relation 2. Uh-oh, we got problems. And the problem child is right there with the 3. Okay, so if you look at that, think about it for just a moment, right? What's the issue? Well, the issue is you're taking one number, 3. You're putting it in this box, this microwave, and you're getting 2 separate things out of it. How is that possible? And the answer is, I mean, it's possible in a relation. I mean, it's not like it's impossible, but it's not a function. A function means that when you put something in, you can only get one thing out. No more, no less. Right? So I can't take the number 3 and get both 8 and 6 out and still be a function. So this is not a function. Okay. And just for a moment, just make a note to yourself. The issue here is you can kind of see it, that repeated 3. That's generally not a good idea, right? So note the repeated 3. Right, if you see x values repeating like that, that's generally a bad sign. Not always, because they can kind of fake it out in a couple ways, but the repeated 3 is an issue. All right, now what about number 3? Relation number 3, that is. Right? How's that going? Well, every x only goes to one y, right? I don't have the number 5 going to 3 and 7. 5 just goes to 3. 6 just goes to 3. 6 doesn't go to 3 and 10. It goes just to 3, and so on. So this is a function. And while we're on the subject, let's think about, just for a second, what kind of function this is. So do you see how y is 3 everywhere? Let's think. Over 5 up 3, over 6 up 3, 7 3, 8 3, right? That, my friends, is a horizontal line. This is y equals 3, if you really want to know. Okay. It's a horizontal line. I better put that in parentheses. Horizontal line. Just always good to be able to spot that kind of thing right in your table. And it'll help us with a question in another page or so. All right, now let's look at 4. 4 has got big problems. So I'm going to tell you right now, 4 is not a function. Now, how can I tell that? Well, do you see how 7 is repeating? See that? See how 7 goes to 1, but 7 also goes to 2, and 7 goes to 3, and 7, that's not good, right? I mean, if it's a function, I'm supposed to be able to put the number in and get one number out. That's it. Right? I can't put the number in and get 3 different things out or 5 different things out. That's not good. So this is not a function. And while we're on the subject, this is, however, a line. It's a vertical line. That's why when you're in your calculator, let's go to look at the calculator for a second. Oh, hold on. There's the calculator. Okay, so when you have the graphing, remember the graphing's all up here on these 5 buttons. So let me press y equals for a second. Okay, now notice what I just said. Y equals, right? Y equals. So I could graph this guy right here. Y equals 3, that's no problem, right? Y equals 3, it'll graph, zoom, 6, horizontal line, everybody's great. But notice what I can't do. There's no x equals, not in this calculator, because this is only graphing functions. Because they're y equals like this, it's not going to be possible to graph x equals 7. Right? Your calculator cannot graph that because it's a vertical line. Vertical lines are not functions. All right, we're done with that one. Now let's take a closer look at this one right here, right? The problem child, one of the 2 problem children. Okay, so I want to look at that one down here. So remember that the issue in particular was these 2 right here. And you could tell they were problematic because they had that repetition. So let's see what that looks like in a graph. Now, I accidentally was a fool here, and I did not have the right scale. So if you look at your y's, this isn't good. This is going up by 1, 2, 3, 4, 5. We need 2, 4, 6, 8, 10. So I'm going to fix it right now, but you'll have to fix it yourself on your own paper if you still have that typo in there. All right, there they are. Sorry about that. That scale again, 2, 4, 6, 8, 10. And what I did was I graphed all the dots. So I went over 2 up 10, over 3 up 8, over 3 up 6, and so on. Right? All right, now when you look at these, you think, okay, so the issues were with these 2 points right here, right? See them? They were the problematic ones. And we saw them being problematic right here in the table, but how does that show up in a graph? So in the graph, it shows up in terms of vertical lines. If the problem is x equals 3, then that means that the vertical line, x equals 3, that's the equation for it, would touch that graph in 2 spots, here and here, right? So that's where the difficulty becomes. So this is not a function because a vertical line, which we all know would be x equals 3, would intersect the graph in let me put this, more than 1 point. Now in this case it was 2, but it could be 3, it could be 4, I mean it could be, oopsie, all sorts of things, right? So the number is not important. All that's important is that it's more than, oh goodness, I'm sorry, more than 1. So as long as it hits it more than once, you're in trouble, right? It's not going to be a function. It's the same pattern you were seeing with the table, but it's different because it's in a graphic form, right? So it's the exact same stuff. It's still hitting it more than once. It's just hitting it more than once in a graph form as opposed to a table form. So this is how to tell from graphs. So from graphs, you can see a vertical line, any vertical line would hit it more than once. That means it's not a function. In the tables, you can see it because you get these repeated x's. There are other ways to do it too, but those are kind of the most common ones. All right, so that, my friends, is the vertical line test. So how can you tell something's a function? Well, if you look at the graph, if a vertical line would hit it more than once, it's not a function. So let's look here. At this particular one, the first one, hopefully you can all spot, that's not a function. Because if I can make this line hit it more than once, right, not a function. Okay, now what about letter B? Letter B is a function. Matter of fact, it's a very particular kind of function that's going to matter a lot to us called a parabola. We're going to be working with that one a lot in chapter 6 and 7, but 7 in particular. All right, and letter C, hopefully you spot, is not a function either because no vertical line would ever hit it more than once. That's not the case for the parabola. Look at the parabola. Here's my vertical line, and as I drag it across, I'm only hitting at 1 point anywhere. But this thing, please, I hit at 2 points all over the place, right? So that is not a function. All right, that leads to another question, which is, are all lines functions? And the answer is a big fat no, right? But let's prove it. Okay, so why am I saying no? Poof, it's like magic. Okay, so diagonal lines are always yes. So diagonal lines are ones that fit into, and it doesn't hurt us to remind ourselves, y equals mx plus b, right? So y equals mx plus b is a function, no trouble, as long as m and b are numbers, everything's great. Okay? So because no vertical line would ever hit them more than once. Horizontal lines, similarly, are also okay because if it's a horizontal line, then it's just going to, vertical line, excuse me, would only hit it once. So that's fine too. The problem child is vertical lines. So the answer is no, because all vertical lines are not functions. Because they would never pass the vertical line test. They're a vertical line themselves, but if you had a vertical line, it would hit that blue line infinitely many times, which means automatically not a function. Okay, so are all lines functions? No, vertical lines are not. That's why your calculator won't graph them. The other two, yes. And you can spot their lines because they'll have x and y to the first power.